Hi students, welcome to Max Point of View. Today we are going to solve each and every theory question from the chapter Electricity Part C. Okay, we have learned the concept video. After that we are solving all the theory questions. After this we are going to solve each and every numerical. Then only we can learn everything about this part. So without wasting any time, we'll start with our first question. Write an expression for the electrical energy spent in flow of current through an electrical appliance in terms of current, resistance and time. Okay, see, you can write the same electrical energy spent in different form also. First I'll show you that. Then using current, resistance and time also we can derive it from it. Listen. Electrical energy spent is nothing but electrical energy consumption, correct? How much electrical energy I can spend? That is nothing but consumption only. So this will be nothing but power into time. This is the original formula, but they want the expression in the form of current, resistance and time. We know power is nothing but I square R and T. This is the expression they are looking for. You can directly write this one also, electrical energy consumption or electrical energy spent. You have to write it in the full form. See, this is the original formula, but they want the answer in form of current, resistance and time. So this is the answer. You can write this one directly without writing this one. Next question. Write an expression for the electrical power spent in flow of current through a conductor in terms of, first one, resistance and potential difference. First we'll write this one. See, we have to write the expression for power in terms of potential difference and resistance, that is nothing but V square by R. Okay, how we got all these things is different expression from the main formula for power is equal to potential difference into current. This is the main formula. Using this only we are deriving all these things. How we got this one, that is what I have explained in concept video. That is why concept videos are very important. Here they are only looking for this one. Okay, write the expression for power spent using resistance and potential difference. Second one, we have to find the same power for a different terms like current and resistance. See, this is the answer. That's it. Our next question, state the SI unit of electrical power. That is nothing but watt. Okay, so why using in the numerical we'll use just W, capital W. This is the SI unit of power. Our next question, name the physical quantity which is measured in kilowatt. Okay, first one they have given kilowatt, second one they have given kilowatt hour, third one watt hour. Okay, it is very easy question. Listen, what do you mean by kilo? Kilo means 1000. Don't worry about this kilo, only worry about the remaining letters. Kilo means 1000, that means nothing but magnitude. Apart from this one, this is the unit. W is just the unit, WH is the unit, here WH is the unit. K means kilo, don't worry about it. So watt is a unit of electric power. Okay, electric power. See, don't worry about K. K means 1000. Watt hour. Power into time is nothing but the electrical energy. Electrical energy. If only watt is there, that means that is power, electrical power. Along with watt, time is the time unit is there. Watt hour, it is electrical energy. Then again watt hour. See, here it is, we have kilo, here we don't have kilo. Then WH is nothing but again electrical energy. Kilo is nothing but 1000, that's it. So these are the units and physical quantities. Our next question, complete the following. See, 1 kilowatt hour is equal to 1 volt, 1 ampere and what something is blank and divided by 1000. See, to remove this kilo we have divided by 1000. So kilo and 1000 will get cancelled. Now what is remain? Watt. Watt is a unit of power. So for power, voltage and current is there. See, these two, okay, will give us the value of power. Power is nothing but unit of watt. So what is remain then? Time. So R is nothing but the unit of time. So H means 1 hour. That's it. See, because of V and A we have W, and because of H what we have? 1 hour. That's it. Next, 1 kilowatt hour is equal to how many joules? This we have learnt in an earlier question, that is nothing but 3.6 into 10 power 6 joules. Our next question, electrical power P is given by the expression P is equal to Q into V divided by time. In that question, our first sub question, what do the symbols Q and V represent? What do the symbols Q and V represent? So they have given P is equal to Q into V divided by time. This is the expression they have given in the question. We have to tell them what is this Q and what is this V. Q is nothing but charge, V is nothing but potential difference. That's it. Okay. In that we have one more sub question. What is that? Express the power in terms of current and resistance and explain the meaning of the symbols used therein. Okay, that we have learnt in previous two questions also. Listen, power in terms of current and resistance. This is the answer. What is I? I is equal to current, R is equal to we know that is resistance. That's it. Our next question, name the SI unit of electrical energy. How it is related to WH. Okay, what do you mean by WH? Watt hour. Okay, SI unit of energy, electrical energy is joules. You have to write it in the form of expanded form. Then they are asking how that is related to watt hour. So watt hour, how this is related to joule? 1 watt hour is equal to 3600 joules. That's it. Our next question, explain the meaning of the statement the power of an appliance is 100 watt. That means, see, power of an appliance is 100 watt. 100 watt of any appliance, you take an example of bulb only. 100 watt bulb means in every second it will consume 100 joules of energy. In every second it will consume 100 joules of energy. That is the meaning of power of an appliance is 100 watt. Our next question, state and define the household unit of electricity. We have few more questions. First we'll understand this one. See, state and define the household unit of electricity. Household unit of electricity will be small k, capital W, small h, kilowatt hour. This is the SI unit, unit of electricity. See, when it comes to physics, no one is going to ask you definition of unit in a board exam. Don't worry about the definition of household unit of electricity. See, these kind of definition they will never ask. When it comes to physics board exam, maximum marks, okay, will be asked when it based on the definition will be 3 to 4 marks. That's it. And definition, okay, definition of units will now never be asked. Till now it is never asked. So don't worry about it. Our second sub question, what is the voltage of electricity that is generally supplied to a house? That means domestic, for a domestic purpose, what is the voltage we are getting? That is nothing but 220 volts. This is the voltage we are getting for our houses. Third sub question, what is consumed while using different electrical appliances for which electricity bill is paid? Why we are paying electricity bill, okay, and what we are using for it? See, we are using electrical energy. That's it. Answer is electrical energy, okay, is consumed for different electrical appliances for which electricity bill is paid. Our next question, define the term kilowatt hour and state its value in SI unit. See, I told you earlier, definition of units will never be asked in physics board exam. So don't worry about definition of kilowatt hour. But there is one more sub question, state the value in its SI unit. So they have given kilowatt watt hour. What is the SI? See, watt hour is the SI unit of electrical energy. What is the SI unit of electrical energy? That is nothing but joule. So watt hour we know. Watt hour is nothing but 3600 joules. We have learnt in previous question. I told you K means kilo. So this into 1000, that is nothing but 336,000,005. So this is nothing but 3.6 into 10 power 6 joules. That's it. Our next question, how do kilowatt and kilowatt hour differ? Very simple. See, kilowatt and kilowatt hour. I told you K means 1000. Don't worry about it. Watt is a unit of power. So kilowatt is a unit of electrical power. Okay, then watt hour is a unit of electrical energy. Kilowatt hour is nothing but 1000 electrical energy. That's it. So kilowatt hour is an unit of electrical energy. That's it. Our next question, what do you mean by power rating of an electrical appliances? How do you use it to calculate? So we have many sub questions. First we'll answer what do you mean by power rating of an electrical appliance. Power rating means how much energy it will use in 1 second. How much energy will be consumed by the appliance in 1 second. That is nothing but power rating. So power rating is nothing but how much energy the appliance will consume in 1 second. So this is the meaning of power rating. Now we'll go for the remaining sub questions. How do we calculate resistance using power? So using the power rating, how we can calculate it? So we need to find the resistance, correct? So this is nothing but V square by P. How do we get this? We have learnt power is equal to V square by R, correct? If you want R, send this one here, P here, that is nothing but this one. Okay. Second sub question, and calculate the safe limit of the current in it while in use. Don't worry about all these things. We need to find the safe limit of current. We need to find current. That's it. So I is equal to P by V. How we got this one? Very simple. Main primary formula for power, voltage and current is P is equal to V into I. We need I, right? Send this V that side. Multiplication will become division. That's it. Our next question, an electric bulb is rated 100 watt and 250 volt. What information does it convey? Okay, very simple. See, 100 watt and 250 volt supply. So what information we are going to get from this data? Very simple. We know what you mean by 100 watt appliances, correct? That means in 1 second, okay, 100 joules of energy will be consumed by the appliance in 1 second. Okay, this is the meaning of 100 watt. What do you mean by 250 volt? We are talking about what? Bulb, correct? Bulb means, okay, in 250 volt, the bulb will be lighted. That's it. In 250 volt, the bulb will be lighted. So what happens? See, for extra information I'm telling, what happens if the voltage is less than 250? Assume we are giving only 200 volts of voltage for this bulb. The bulb needs 250 volts, but we are providing 200. What happens then? Don't you think the bulb will glow? Bulb will glow, but with the less intensity. To get the maximum intensity from that bulb, light intensity, we need to provide 250 volts. That's it. That is the meaning of 100 watt and 250 volt voltage. Our next question, list the names of 3 electrical gadgets used in your house. Write their power, voltage, all those things will not, these kind of questions will not be asked in board exams. So we are not going to discuss this one, but for your reference you can calculate and get the answer for this question. Our next question, 2 lamps, one rated 220 volt 50 watt. So 2 lamps, lamp 1 rated as 220 volt and 50 watt, and they have given one more lamp that is 220 volt and 100 watt are connected in series with the main voltage 220. Explain why does the 50 lamp consumes more power. For this question, see, voltage and power is given. In both the cases we can find the current and we can say which this one lamp is using more current, more the current value, okay, more will be the power, correct? But they have given one hint. See, they are connected in series. If these two are connected in series connection, we know in series connection current will be same. If we find current also, we cannot predict which is going to consume more power. So what is left? Resistance. See, all those hints, in series connection current will be same, in parallel connection voltage will be same, all those will be discussed in concept video. So my suggestion is learn the concept video, then we can aram se solve these kind of questions. See, if you are finding current, okay, for these questions, that will be completely wrong, because we know in both the lamps are connected in series. So in both the lamps same current will be flowing. So we'll go for resistance. Okay, power is related to only 3 things: voltage, current and resistance, correct? Voltage is given. In both the cases voltage is same. In both the cases we got to know current is same. So we cannot use these two. We have only left with resistance. How can we find resistance using voltage and power? R is equal to, so this is lamp 1, right? So R1, R is equal to V square by P. This we have learnt earlier. What is the voltage given? 220 square, right? So 2 times I'll write, divided by power is 50, 0. So answer will be 968 ohm. Okay. In the second case, okay, second lamp will find the resistance. See, again same formula. So voltage is same, 220 volts into 220, because it is V square divided by 100. So 22 into 22 square is nothing but 484 ohms. So in which lamp resistance is more? R1, correct? So if more say R1 is greater than R2, therefore P1 is greater than P2. See, which lamp has more resistance, that lamp will consume more power. Our next question, name the factors on which heat produced in a wire depends when current is passed in it. State how does it depends on the factor stated by you. So first we have to state the factors affecting heat produced in the wire, then we have to tell them how that is affecting them. Okay, so first we will write the formula. In the formula only we are going to get everything. H is equal to I square R T. Okay, so what are the factors affecting heat produced in a wire? Current, resistance and time. Current, okay, so we are talking about heat energy, right? So heat energy and current, heat energy and resistance, heat energy and time. So these are the factors affecting heat energy. Now we have to tell them how does it depend on the factors, how heat energy depends upon these factors. See, heat is directly proportional to current. That means if current is more, okay, heat energy will also be more. Directly proportional. See, this symbol represents directly proportional. If I write 1 by I, that means, see, the same symbol we are using, but this is 1 by I, correct? So this is not correct. I am telling the difference between directly proportional and inversely proportional. The symbol is same. If I write it in the numerator, directly proportional. If I write it in denominator, it is inversely proportional. Now heat is directly proportional to current. You can write like that, or else if current increases, heat energy also increases. That's it. Next, heat energy, okay, all of them are in numerator, right? So all of them are directly proportional. Heat energy is directly proportional to resistance. That means if resistance is more, heat energy will be more. How? Heat energy is directly related to time. It is also directly proportional. If the time, okay, the current flowing in a current conductor is taking more time. Assume current flowing in a conductor for 15 seconds and current flowing in the same wire for 1 hour. Do you think the heat energy will be same? No, right? More the time, more will be the heat energy. That's it. Now we have solved each and every theory question from the chapter Electricity Part C. So after this one, we are going to solve each and every numerical in the textbook. So after completing the concept, we have solved all the theory questions. Now we are going to solve numerical questions. All these videos are available in the description box. Once we learn everything, all the three, then only we'll get to know 90% of the concept. Remaining 10% application oriented questions. For that, if you have this much concept, you can aram se solve any application questions. Thank you.